Hello and welcome to Maths with Mr. Amison. Today I'm going to introduce a new style of video, and that's goal-free problems, which are basically training sessions to help you approach challenging questions that are usually 3 or more marks in a GCSE exam, where we break down the question into its different components, and rather than trying to reach a specific target or goal, we focus on what we can do. I'm going to start with advanced trigonometry. That will be useful for you to understand how the sine rule and the cosine rule work before watching the rest of this video. So if you don't understand that, then this video is not for you, and you need to go away and learn how they work before continuing. So what things can you tell me about this shape here, this diagram here? This was from a GCSE question. I've taken out all the writing. Just figure out what you can about this problem. It's worth pausing this now and having a go at figuring out as much as you can about this diagram. So now you've had a chance to have a go yourselves. Take a look at what we know. Well, let's start with the obvious. The obvious points that we can make are, we have two triangles, and they, as far as we're aware, they are both scalene triangles because there are no apparent right angles in the diagram. It looks like this angle here may be close to a right angle, but we don't know for sure. There's no information given about that. So just taking a look at what we know. The next thing we need to do is look at what we don't know. So if we take a look here, the line SQ and the line RS, they are both missing lengths. If we think about it, there is one of these lengths we can calculate based on the information that we have, and that is the length QS. And to do that, we can use the cosine rule. C squared equals A squared plus B squared minus 2AB cos C. Now, our C is here because that is opposite our angle, so our angle C is here and our length C is here. So if we call that X, then we end up with a solution of X being the square root of 304. Now it's worth noting that with this example, you have 2 times 8 times 12 next to cos 120. Don't forget that the 2 times 8 times 12 needs to be multiplied by cos 120 before you can combine it with the 8 squared and the 12 squared. So we can't do 64 add 144 take away 192 before we multiply the 192 by cos 120. And I'm not going to dwell on that, but take a look through it, make sure you understand it. Next thing we can notice is that this length, we can't calculate this length straight away. We'd need this angle here because it's opposite the length. So we should also notice that we have all of these missing angles. Now, some of these angles we can calculate using the sine rule. These angles here. Let's take a look at angle S. Angle S, if we use the sine rule, then we get this working out here. Take a look through it, make sure you understand it. But we get S is equal to 36.6 degrees following the sine rule properly. So we can calculate that angle because we have this length opposite this angle, and the length 12 is opposite the angle S. So angle S is 36.6 degrees. Angle Q, we could then use 180 degrees in a triangle to figure out the angle Q, or we could also use the sine rule as shown here to get 23.4 degrees, which is exactly the same as we would have got if we used 180 degrees in a triangle. Finally, we can calculate angle R again using the sine rule because this length is opposite our angle R and the length QR is opposite our angle at the point S in this same triangle. So we can do the sine rule here, sine R over root 304. I'm using root 304 because it's more accurate than the 17.4. This is just the three significant figures, if you remember, from the way we worked this out. So keeping this as accurate as possible will help us to get an accurate value for R. So follow the working through, pause it if you need to, make sure you understand how that works. So we get an angle of 61.6 degrees here. We then have this missing angle, which we can calculate using the fact that there are 180 degrees in a triangle. So 27 add 61.6 add angle Q would equal 180. We can rearrange that to get Q is equal to 91.4, which was pretty close to the right angle, but it wasn't a right angle. We could do more things with this. We could use the area sine rule to figure out the area of either one of these triangles using this angle and these two sides, or the angle Q and these two sides. Now we have the angle Q. But if I plug the original question back in, it was to work out the size of angle SQR, giving your answer to one decimal place. And you can see as part of the process here we've done that. So I'm not going to worry about the other things that we could have done, but I want us to think about which things were useful to get us to this point. So pause and have a think about that. So now you've thought about it, these two angles didn't really help us to find this one. So these two angles were useless. The missing length at the bottom was also useless. We could have calculated this missing length at the end here after we'd got 91.4 degrees using either sine rule or cosine rule. It really doesn't matter at that point. Lots of different ways of finding that missing length. But it wasn't important for finding this here. So this line here was useful. Why do you think that was useful? Well, it's useful because this line is what links the triangle PQS to the triangle QRS. So whenever you've got triangles in a problem solving question, it might be wise to try and find what links the two. In this case it was this line. Sometimes there'll be areas that link the two written in the question, but you just got to pay attention. So that's a useful thing to calculate. And then this angle up here, well, if we don't worry about finding that angle, we just worry about finding any angle. It really doesn't matter, because in triangles there are 180 degrees. This was a really useful angle for us to find, and it was fairly standard. It was a standard sine rule example where QS was opposite the angle at R and QR was opposite the angle at S. So this was fairly standard to find, and then it was just a matter of 180 degrees in a triangle. Now, all of that all put together is really quite complicated, but when you break it down into those smaller steps, didn't worry so much about the question, then there were things that you could do. There were approaches that you could do to the question. You could do something. So, thanks for watching. I will be making some more goal-free problems videos. Keep doing maths, keep working, and stay safe.